All right, so in this video here, we are going to be going over writing information in point slope form. The information we're going to be given is two ordered pairs, or we're going to have words writing that in point slope form. If we have a table of a linear function, writing that in point slope form, or if we have a line on a graph, we're going to be writing that in point slope form. So point slope form, one of the reasons it's super important is if you have some information, like up here, we're talking about face mask sales in different years, and we can take this information from the words and we can rewrite it or arrange it as a table or even as ordered pairs. And from either the words, the ordered pairs, or the table, we can find the slope or the rate of this here. But for this example here, the y-intercept or the initial or the start amount ends up being negative 248,585 billion masks. So in this case here, really big, awkward number. And in this case here, it's not super useful for the information that was provided to us. So we will come back to this example later in the video and kind of break down how we use point slope form with that. Quick review for the linear equations of lines that we have so far. Slope-intercept form, y equals mx plus b. Remember that slope is going to be the m, so that's going to be your slope or your rate is the m. And then the b, that's going to be your initial amount or start amount or the y-intercept. Point slope form, the m is the same, y equals m, x minus x1 plus y1. In this case here, that x1, y1 is going to be a point on the line. It's not the start amount, it's just some other point on the line or another piece of information. Now, this is one form of point slope form. Some people like this form better, where the y1 has been subtracted to next to the y, so it's y minus y1 equals m x minus x1. But for this video here, we are going to be working with this top version here. Now, there is a third linear equation, and that's standard form. That's going to be ax plus by equals c. That's where you have the x, the y, then the equal sign. Whereas these two up here, it's y equals and y equals. All right, so we're going to go ahead and jump right into an example here. We're going to write an equation for the line through these 2 points here, negative 2, 1 and 4, 9. So we can start by finding the slope of this line here. So slope, remember, that's rise over run. So here we go with a rise. Remember the xy pairs, the y tells you how far up or down it goes. So for the rise, we're looking at 1 to 9. And you can like use your fingers or just count or whatever. 1, 2, 3, 4, 5, 6, 7, 8, 9. It went up 8. Now for the run, that's going to be the x's. Remember xy. The x's tell you how far left or right the information goes. So we're going from negative 2 to positive 4. This one does jump over 0, so it does make it a little bit complicated. But from negative 2 to 0 is 2, and then we got to go another 4. So that's going to make a plus 6, or to the right 6 for the run there. Now, if you do like using the slope formula, you sure can. y2 minus y1 over x2 minus x1. And for this case here, that y2, that's going to be the y value from the second point. So here's our second point here, and the y value is going to be a 9. y1 is the y value from the first point, so that's going to be replaced with a 1. x2 is the x value from the second point, so that's a 4. And x1 is going to be a negative 2 because it's the x value from the first point there. Now, we can do 9 minus 1 pretty easy. That makes 8. Minus a negative 2, in our brains, we're just going to change that to a plus 2. So 4 plus 2 makes 6. So there we go. We have 8 over 6, or we can think 4/3 as the reduced form. After you find the slope, now it's time to write an equation. So we don't know the y-intercept. So that's kind of an issue there. We do have points and a slope. So use point slope form. That's what it's for. If your information is points and slope, point slope form. If you know the y-intercept, then use slope-intercept form because you know the intercept. So here we go. So there's a point slope form there. And so we're just going to rewrite this whole thing, and we're going to replace the m with the slope, x1 for the x value, and y1 for a y value. So here we go. So the m, that was 4/3 or 4/3. x1, that's going to be the x value from the first point. So that's going to be a -2. So -2 replaces the x1, and then the y1 gets replaced from the y value from that point there. So that's going to be a 1 there. And then we do clean it up, right? So 4/3 minus a negative, we'll just change that to a plus, and then the 1 goes there. So there's an answer there. If you wanted to use the other ordered pair, if you wanted to use the 4/9, might have been a little bit easier for you. Your equation would have looked like this. So go ahead and try this one out on your own, pause the video, then come on back and see how you did. So for writing an equation for a line through these 2 points, first find the slope. So the rise, that's the difference in y, so we're going to start at -7 and stop at 3 and figure out how much that goes up. So it does cross over 0, makes it a little bit trickier, but -7 to 0 is 7, and then 3 more to get to the 3, so that's going to go up 10. And then for the x's, we're going from -3 to -1. So think like temperature, it's 3 degrees below 0, and it's going to go up to 1 degree below 0. So it's just going to go up 2 degrees. So our slope will be 10 over 2 or 5. Now, if you did want to use the slope formula, here we go. Looks like this. y2, that's going to be a 3. y1, that's going to be a -7. And then x2, that's going to be the -1. And then x1 is going to be the -3. Right? Subtract a negative in your brain, just change that to plus, and you still end up with 3 plus 7, that makes 10. -1 plus 3 makes a 2. You still end up with 10 over 2 or 5. Now, looking here, the information we have is points and slope, so we're going to use point-slope form. So here we go. Y equals m, x minus x1 plus y1. Replace the m with the slope. Well, we already know that. That was a 5, so that gets replaced there. x1, you can use either point here, whichever one you think is going to be easier. So this one is probably going to be easier. It's got smaller numbers, so we're going to use this for our point. So the -1 goes there, and then for y1, that's going to be the 3 there. So 3 replaces the y1, and then the x1 is replaced with a -1. Clean it up a little bit. Instead of minus a negative, we're going to change that to a plus there, and there is an equation in point-slope form. Now, if you did want to use the -3, -7, this is what your equation would look like here. Now, sometimes teachers ask you to write your answers in slope-intercept form. Well, super easy. All we're going to do is simplify either of these equations here, either this one or this one. So we'll go ahead and take the top one, and then you just simplify. Just do distributive property, add like terms, that type of stuff. Just clean it up, right? So in this case here, we can do distributive property. So we can distribute the 5 times x, that's 5x, 5 times 1, that's a plus 5. And then we still have the plus 3 from here. Now it's just add like terms, right? Y equals, and then we only have one x term, so 5x's. And then we have these 2 constant terms here, 5 plus 3, that's going to make a plus 8. So now we're going to switch gears and go from a table into point slope form. So here we go. Step 1, find the slope. Okay, so we're going to remember slope, that's rise over run. That's the change in y's over the change in x's. We'll start out with the y's. So remember with tables, we read them from top to bottom. So we're going from -1 to 9 to 19. Those are going up by 10s. So that's going to be our change in y's is going to be 10. Next up, let's look at the change in x's. The x's go from -3 to 2 to 7. Those are going up by 5, right? 2 plus 5 makes 7, or 7 minus 2, again, makes 5 there. You can use subtraction also. So the x's go up by 5, so x's go up by 5. So rise over run, 10 over 5, that's going to make 2. Boom, we have found the slope. Now that we found the slope, look at the information. We have 3 ordered pairs here, -3, 1, 2, 9, and 7, 19. And we have the slope. So we're going to use point slope form. If we knew the y-intercept, we would use slope-intercept form, but we don't. So here we go. So point slope form, we're just replacing the m, the x1, and the y1 with values. So here we go. So the m, we already know that. That's going to be a 2. Now the x1 and the y1, you can pick any row here. So just figure out which one looks easiest. So in this case here, probably this middle row is going to be easiest. It's got small-ish numbers and no negatives. So boom, we can put a 2 in for the x1, and then the corresponding y1, that's going to be a 9 there. And we're done. So that's an easy way of doing it. Now, if you did want to use any of the other ones, you can use, like if you're using this top row here, that would be x minus a negative 3, which is the same thing. Minus a negative is plus 3 there. And then we have the plus y1 would be a minus 1. Or if you wanted to use this bottom row, it would look like this. So you can use any of those that you want. So go ahead and try this one out on your own. Pause the video, then come on back and see how you did. So we're going to write an equation for this table here. Now, if we notice there is no x equals 0 row on here, so we do not know the y-intercept, so we are going to be using point slope form. So here we go. Do need to find the slope first, or the value for m. So remember, slope is rise over run, change in y's over change in x's. So for the y column, goes from 10 to negative 5 to negative 20. Those are going to go down by 15. So we got a negative 15 for our change in y's, or our rise. Now for the run, we're going to look at the x column, negative 2 to 3 to 8. Those are going up by 5. You can use subtraction with this also if you want. 8 minus 3 does make 5. So our change in x's is going to be a 5. So for the slope, that's going to be negative divided by a positive, so that'll be a negative, and then 15 divided by 5 does make a negative 3. So now that we know that our slope is going to be a negative 3, so we replace the m with a negative 3. Now for the x1, y1, again, you can pick any row on here. We're just going to use the top row here. We're going to go x minus x1, x minus a negative 2. Minus a negative, we're just going to rewrite as plus 2. And then the y1, the corresponding y value is going to be a 10. And boom, there's an equation for this table here. Now we can also use the middle row, would look like this, where it's x minus x1 is a negative minus 3, and then a negative 5 there. And then for that last row right there. Now, sometimes your teachers will say, hey, I don't like point slope form, so rewrite this in slope intercept form. Not a big deal. Here we go. So we're just going to clean it up. We're going to simplify. So negative 3 times x using the distributive property is negative 3x. Negative 3 times positive 2, that's going to be a minus 6. And then we still have the plus 10 right there. And then it's just add like terms. We only have one term that has an x, so that's just going to be negative 3x's. And then we have the constant terms there, negative 6 plus 10. And again, we can just think subtract 6, because it is a subtract 6 from 10 makes 4. And there we go for slope-intercept form. So now we're going to go ahead and switch gears again and look at writing an equation from a graph. So here we go. We can find the slope. Remember, with finding slope from a graph, you're looking for 2 nice points. So that's, so going from like here, there's a nice point there. Not nice, not nice, not nice, not nice. Oh, there's another nice point there. And that's it. We only have 2 nice points. And remember, those are going through the grid lines here. So like this one here, we know it's exactly 2 on the x, but that y we're not quite sure of, so that's not a nice point there. And then like this one right there, we know that's a 3 on the y, but we're not exactly sure what that's going to be on the x. So nice points that go through the grid lines. So now we're doing rise over run. So we're going to start on the left and work our way to the right. So that's going to go down 4, down 1, 2, 3, 4, and then it's going to go over 1, 2, 3, 4, 5. So we know that our rise over run is going to be down 4, and then over 5. So there's our slope. We're just going to write it as negative 4/5. Now for this one here, check this out, because a lot of people, they want to use slope-intercept form, but you have to know the y-intercept. Now look here, that's where it crosses the y-axis right there, 4.23, 4 1/4, not quite sure. So we don't have the exact y-intercept. But we do have this ordered pair, this coordinate point, and this point here. So we have points and slope. So we're going to use point slope form because we don't know the y-intercept. So here we go. Y equals m, x minus x1 plus y1. The m, that's going to get replaced with a slope. That's negative 4/5. Boom. Now for the x1, y1, you can pick this point or you can pick this point here. So in this case here, I chose this first one, the one that's most on the left, although this one may have been easier because it's both positives, quadrant 1. So here we go. So we got negative 1 for the x, and then the 5, that's going to go for the y1 there. And remember, anytime you subtract a negative, you just change it to plus. So you can do that in your head, or you can write it out, or you can write minus a negative and then change it to a bigger plus, or however you want to do that. So that's going to be an x plus 1 there, x minus a negative 1, and then the y, that was a 5 there. So there's an equation for the line here. Now, if you did want to use this point right here, probably would have been a little bit easier. Just replace the x1 with a 4, and the y1 gets replaced with a 1, and boom, there's your answer there. So let's have you go ahead and try this one out on your own. Pause the video, then come on back and see how you did. So finding the slope, we want to find nice points. So there's a bunch of nice points along here. There's one here, and there's also one here. So going from left to right, there's a bunch. One there, one there, one there, one there, one there. So using any of those, totally fine. Rise over run, it's going to go up 2 over 1. So we know the rise 2 over 1. And then we don't know the y-intercept. So because the y-intercept is going to be all the way like off the screen here. So we know the slope is 2 and we have points, but we don't know the y-intercept. So we're going to use point slope form. We know points, we know slope, use point slope form. So here we go. Y equals m, x minus x1, and then plus y1. Replace the m with what it's equal to. In this case, that's a 2. And then the x1, you can choose any of these points along here. So I went ahead and just went with this point right here. So the x was a -4. So x minus a -4 makes x plus 4. Minus a negative is just plus. And then the y1, that's a 2 here. So boom, done. You're ready to move on. Now, again, if you wanted to use this ordered pair up here, that would have been a 3 for the x, or a -3. So minus a -3. So, and again, with these, you just switch whatever the value of x is for your x1. So if it's a negative, you make it a plus. If it's a positive, you make it a minus. And then if you did want to use this ordered pair, it'd look like that. And this is probably the best one to use, by the way, because you have a 0 in there. 0 is the easiest number to add, subtract with, right? And then if you wanted to use this one down here, that would be the equation. Or if you wanted to use this one all the way up here, you could have used that one. Now, again, some teachers, they don't like point slope form. So they're all like, no, 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 we want everything in slope intercept form. Not a big deal. Just go ahead and clean it up, right? Simplify. So here we go. We can distribute. So that's going to be 2 times x, 2x, and then 2 times 4 is going to be an 8. And then we still have the plus 2 there. And then add like terms, we only have one term with an x, so that's going to be 2x there. And then the 2 constant terms, 8 and 2, that's going to make a plus 10. So now we circle back to the first example we used in this video. It is estimated that there were 278.9 billion face mask sales in 2020 and 402.1 billion in 2021. Write a linear equation to model this data. So with this here, we are talking linear equation, so we can go ahead and start by thinking about finding slope. Now for finding slope, a couple of different ways we can look at this. We can look at it as a table, or we can look at it as ordered pairs or a coordinate. A lot of people like seeing it this way instead because that's super duper similar to what we did at the very beginning of the video, just looking at ordered pairs or coordinate points. So here we go. To find the rise, that's going to go from 278.9 to 402.1. You can also look at it here. We're going to go from 278.9 there to 402.1 billion there. And we're just going to use subtraction to figure out what that difference is or how much it went up. So 123.2. And now for the run, it's going to be looking at the x values. This one here, not that tricky. We went 1 year. So there we go, 1 year there. So our rise, we can also look at the table and then the years for the run there. So rise, change in y's, 123.2, and 1 for the change in x's, or in 1 year. Now, we normally don't like seeing the 1 in the denominator, so we're just going to write it without the 1. And do remember, we don't really like decimals in our fractions either. So now that we know the slope, now we look at the other information we have. We do not have the initial amount or year 0 or the y-intercept. What we do is we have some coordinate points and we have the slope, so we're going to use point slope form. And we can use either piece of information there, the 2020 or the 2021 version there. So there's our point slope form. Y equals m, x minus x1 plus y1. Now we're just going to replace the m, the x1, and the y1 with values that they equal. The m, we already found that out. That's the slope or the rate per year, 123.2. x1, y1. Probably use the 2020 information. It's got smaller numbers, so x1 is going to be replaced with 2020, and then y1 is going to be replaced with 278.9 from there or there or there. So there we go. Now, some teachers, they do want to see it in slope-intercept form. So here we go. We're just going to distribute and then add like terms. So we're going to go 123 times x, 123.2x is what that equals, and then we're going to do 123 times negative 2020, and then we're going to add like terms with the 278.9. So, and that's going to give us our y-intercept there. So there we go. Now again, on this one here, if we're looking to like summarize what our equations mean, this, and again, you need to be able to restate this information from your equation. It's a summary statement. So, number of masks sold goes up by 123.2 per year. In the year 2020, it was 278.9. Now, if we're looking at slope-intercept form, that information is kind of irrelevant, right? So here, mass sold is going up by 123.2 per year, starting at negative 248,585. So kind of irrelevant for year 0, that negative billions of masks were being sold. So that's why, like in this one here, like if you try plugging in for 2030, this arithmetic is probably going to be a little bit easier than this one. But again, it kind of depends on what your point of view is and what you prefer doing. So let's have you go ahead and try this one out on your own. Pause the video, then come on back and see how you did. So here we have a scuba diver under the water after ascending or going up for 4 minutes. He is 164 meters under the water. Then at 10 minutes, he is 101 meters under the water. So here we can find the rate or slope of this information here. He's going from 164 to 101 meters. So that's going to be 63 meters. He went up, and that's just using subtraction. And then how long did it take him to do that? Well, from 4 to 10 minutes. So that's going to be 6 minutes. Again, you can use subtraction. So we know 63 divided by 6 makes 9. So his rate is 9 meters per minute. Now, here we are going to be using point slope form because we don't know his starting amount. We know his 4 minutes amount and his 10 minutes amount, but we don't know the 0 initial y-intercept amount. So point slope form is what we'll use. So let's go ahead and replace the m, the x, the y1, even this x and this y with what they go with. So here, instead of a y, we're going to use d for depth. M, that's going to still be the rate, and instead of an x, we're going to use t for time in minutes. So the m, we already know the rate is a 9, so that gets replaced with a 9. The x1, that's going to be the x value there from our first piece of information, and then with the y1, this is going to be under the water, so it's going to be a negative 164 meters. So some people, they like seeing it better as ordered pairs like this. So you can totally rewrite it this way and then go back to example 1 and see how we did it that way. We're just doing change in y's over change in x's if you want to look at it that way. Or if you like the table, you can just go how far this way for the y's, how far this way for the x's. Now, sometimes you'll be asked to write your answers in slope-intercept form. So here we go. So that's going to be y equals mx plus b. To go from point slope form to slope-intercept form, simply simplify. So we're going to have d equals, now here we're going to use distributive property, 9 times t and 9 times negative 4. So 9 times t is going to be 9t. And then for this part that we're adding here, the y-intercept or the constant term, that's going to be a 9 times negative 4. And then we're going to subtract 164 from that when we do the add like term. So that's going to make a minus 200 there. So there's your slope-intercept form. Now we can think of these as summary statements from the information up here, and each one kind of gives us some different information. So here we go. Thinking back to what do these equations mean? The depth of the scuba diver is ascending 9 meters per minute, and then at 4 minutes, he was under the water 164 meters. So that's what it looks like for point slope form. Now, the summary information we have for slope intercept form is the depth of the scuba diver is going up or ascending 9 meters per minute, and he started under the water at 200 meters. So that's what the summary statements that refer back to our original information would sound like there. So just to kind of wrap up here, point slope form, that's y equals m, x minus x1 plus y1, where m is the slope, x1, y1 is a point on the line. Remember slope, think rise over run, change in y's over change in x's, or you can use the slope formula. Now, number 1, find the slope, and then number 2, plug in that information, replace the m, the x1, the y1 with the information from the problem. And remember, one of the big things you do need to know is that you going to use point slope form if you do not know the y-intercept. If you know the y-intercept, use slope-intercept form. If you don't, then use point slope form.